It's so active, it uses up so much energy, so many calories, that in the process of working, it generates a lot of waste heat. And the body uses that waste heat to help keep you warm. Gosh, if you're really cold, your brain will command your muscles to contract violently and shivering. You don't need them to be vibrating like that, but they do it because, as a consequence, they produce a great deal of waste heat. So what we're going to do is look at the microanatomy of skeletal muscle. And here are a couple pictures of muscle. Here's a muscle cell under the microscope. One is here, another's here, another's here. And here are worm-like skeletal muscle cells. Both these pictures show the features I want you to know. They're really well innervated. So this is a neuron, a nerve, and it attaches to the muscle cell to stimulate it. A typical muscle cell has more than one contact for a nerve. It might have many. So they're very well innervated. They have really good nervous system supply. They're very well vascularized. So these little red ropes here are tiny little blood vessels or capillaries that wrap around and over and lace around muscle cells. So every muscle cell has an excellent blood supply, and man, they need it. They're metabolically demanding, they need a lot of oxygen, they need a lot of glucose or sugar to run metabolism, and at the same time they generate a lot of waste CO2 that's also got to be picked up by the blood supply. So being well vascularized means good delivery of necessary oxygen and sugars, and good quick removal of waste materials like carbon dioxide. Okay, so we need to talk about the connective tissue sheathings around muscles. And so I want to cross off the systemic fascia and the deep fascia, all right? And these are connective tissue wrappings inside your body cavity. Okay. Instead, I want to specifically talk about the muscle fascia, the connective tissue of muscle. Remember when we were talking about autoimmune arthritises, like rheumatoid arthritis, and I said it's an immune system disorder where the connective tissue of the body is attacked. So of course the joints are affected, but the muscles can be deeply affected, and you're finally going to see why. Individual muscle cells are soft and tender and delicate. If they're going to contract together and pull as a team, they have to be wrapped in connective tissue sheets that wrap them together and keep them strong. Otherwise, it's like trying to make a bunch of really overcooked spaghetti work together. It just breaks apart. So you'll see that there will be layers of wrappings around muscle cells. So here's a whole muscle that's been cut in cross-section, and we're going down to an individual muscle cell. Now, each individual muscle cell is filled with contractile bundles we'll learn about later, but I don't want to look at them right now. Each individual muscle cell is wrapped
That's exactly what they're like.
a connective tissue wrapping called an endomysium. Probably still wrong. Now it's loose, it's sticky, but what it does is it allows a bunch of muscle cells, and here they are here, to stick closely to one another, right? So they package together, and those packages of groups of muscles, here's an endomysium right in here, around one muscle. These groups of muscles are packaged together in a perimysium around. Now what that does is it bundles,
Is it like a fiber material, or is it more like liquid?
So the endomysium is more like mucus.
Okay.
It's more like areolar tissue. It's really loose, but it allows the guys to stick together. And they stick together in working bundles of maybe 2 to 2,000. These are functional units we'll learn a little bit more about together. And these cooperative bundles are wrapped in something white in fibers that looks just like the stuff you see on raw meat, really white.
Mm-hmm. I was just thinking about that.
It's called the perimysium, and it wraps the bundle into a functional unit we call a fascicle. So when you look at a big muscle, like the muscle of your biceps, it's actually packaged into individual fascicles of 2 to 2,000 individual muscle cells. And these guys are unique because some contract early when work is light, others contract later on when the whole workload is very heavy. So they have different assignments within the whole contracting muscle. So they're all wrapped together in this beautiful cooperative unit. And then finally, get the right terms? Endoperi-epine. The whole muscle, like you can pull it out and look at it, like you might see with, there's certain cuts of meat that are just one whole muscle. What is it? There's a
Loin.
yeah.
Loin.
Pork loin, it's just one muscle. So the whole community of fascicles, of teams, muscle teams working together, the whole biceps, the belly of the biceps, is wrapped in a fibrous white connective sheet called epimysium. Now, if you've ever worked with raw meat or looked at meat at the meat market, you can see these white sheets of connective tissue running through the meat. And some meat has more connective tissue sheets than others. Hard-working muscle, like your thigh muscle, tends to have lots of connective tissue sheet wrappings. For example, leg of lamb. I bet nobody here cooks. You do. So leg of lamb, it's like, I like lamb, but there's way too much connective tissue in it. And that's because it's the thigh muscle and the butt, the leg of lamb, and it apparently is a hard-working muscle. So it's got all these white fascial connective tissue sheets that are no fun to eat. And tender meat has, the connective tissue sheet wrappings are lighter and more delicate. And that's what makes the meat much more tender and easy to chew. So a low-load muscle, for example, might have very little obvious white connective tissue. So you look at like a skeleton here, and some of these muscles, when you take them out, they've just got these big white sheets of connective tissue all over them because the wrappings are very, very thick, especially that upper and last wrapping. Now we'll get back to that a little bit when we start talking about motor units, how muscle cells form these cooperative communities of fascicles that do light, medium, and heavyweight work in the initial, middle, and hard end of the muscle workout. So a few other anatomy terms that I want you to know that you probably already do. A tendon is a long, ropey connective tissue with rope that attaches a long muscle down to a bone or ligamentous wrappings. So when you look at a muscle like the sartorius muscle here, which is a long, strappy muscle that crosses from the outside of your thigh to the inside of your thigh, it's one long, ropey muscle. And all the connective tissue layers of it, let's go to the picture here. All the connective tissue layers in that sartorius muscle, the perimysium around the individual muscle cells, the endomysium around the individual muscle cells, the perimysium around the working bundles, and then the epimysium around the whole muscle itself.